In this video, we're exploring a few properties of an electron if I'm given the wavelength of the electron. So the de Broglie wavelength is 4.5 times 10 to the negative 10 meters. In part A, I want the momentum of the electron, and then I want the speed. And then finally in part C, I'm asked what potential difference would be required to give the electron this speed. So in a sense, I could interpret this problem as, how do I calculate the potential difference that's required to get a desired wavelength in, for example, an electron microscope? So first we'll look at the momentum of the electron. And momentum is just given by h over lambda. And when I crunch the numbers, I get 1.47 times 10 to the negative 24 kilogram meters per second. Now in part B, I want the speed of the electron, and provided this speed is not an appreciable percentage of the speed of light, we don't have to worry about relativity. So I can just say momentum is mass times velocity. So V is going to be P over M. And I have to look up the mass of the electron. And when I crunch the numbers on this, I get 1.61 times 10 to the 6th meters per second. Remember, the speed of light is 3 times 10 to the 8th meters per second. So this is less than 1% of the speed of light. And I don't have to worry about relativity. In part C, I want to find the accelerating potential required to give the electron this speed. And probably the easiest way to do this is to just find the kinetic energy of this electron and express it in electron volts. And then I know how many volts I need the electron to pass through to have that much energy. Now, of course, I could just plug into 1/2 mv squared because I already computed V. But often we're in a situation where what we know is the momentum. And it's really nice to be able to directly express the kinetic energy in terms of that. And I'm going to multiply by 1 factor of m in the numerator and denominator. And in that numerator, I recognize the square of the momentum. So I can rewrite the kinetic energy as p squared over 2m. So I take my answer for the momentum, and I get 1.19 times 10 to the negative 18 joules. But I want to convert this to electron volts, so I multiply by the conversion factor. An electron volt is the energy of an electron passing through a 1 volt potential difference, or 1.6 times 10 to the negative 19 joules. And I found out the kinetic energy of this electron is 7.41 eV. Well, that's the energy you get by accelerating an electron through a 7.41 volt potential difference. So what's the required accelerating potential to get our electrons to have this much energy? That's just 7.41 volts. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.